Good morning, everyone. I am Autumn Jackson Bartholomew, a student at the Prince George's Community College and an incoming physics major here at the UMD. Over this summer, I had the privilege of being mentored by Landry Horenbe and Dr. Carlos Romero through the GradMap and Trend programs. I worked on digitization of analog gauge readings from video footage at the Centrifugal Mirror fusion experiment. Today, I'll go over what is the purpose of the centrifugal mirror fusion experiment. Why is my program written this summer important to it? The methods used within the program and my final results. So the main purpose of the centrifugal mirror fusion experiment is to investigate magnetized plasma configurations in order to create non-carbon energy. And this is important because carbon source energy leaves waste, radioactive waste, which is not good for the environment. So within the CMFX, non-carbon emitters such as hydrogen is used to create plasmas. The hydrogen is heated to very high temperatures, and these plasmas are then confined using repurposed MRI magnets, shown here. These magnets, they utilize liquid helium, which is used to cool them down, making them superconductive, allowing them to transmit vast amount of electric current during the experiment. The chambers which host the liquid helium, in the past, there was a small incident where some of the pressure, one of the compressors that is used by the magnet had failed and some helium was lost, and therefore costing the project at least $15,000 in loss of funds. So this is where my program comes in. My program will be able to read the gauge on this chamber and send out alerts. Also, when because the lab is a high magnetic field environment, and also when the plasmas are discharged, high voltage and high current are present, it is not practical to manually go in there and check it yourself. Thus the code. So the methods used within this code, I first load the live stream from the camera's IP address. I then take frame captures. After that, I manually enter the coordinates for the dials. In future, I have been testing the Hoff circle transform. This will automatically find the center of the dials, but for now, I manually entered it. Then the midpoint is then used to polar transform the dial. This turns the circular dial into a strip of data, allowing me to take a thin strip of it here in the red that only has the needle pointer. I then calibrate the gauge readings to legend values. After that, the thin strip of data that was extracted before, I then plotted it and calculated the minimum pixel value. In Python, normally the darkest colors have the least value, hence the calculation. I then use this value and plug it into equations I derived to give you a pressure reading. Here it shows that the reading is approximately 0.9, and it gives the reading of 0.9. Also, the program is able to send alerts if readings are outside of the set threshold. Here I set the threshold to 3 for alert testing. The reading was above 3, so a test alert was sent out. So in conclusion, the program can give pressure readings of analog gauges on superconducting coils and compressors near high voltage capacitors in the centrifugal mirror fusion experiment. And also it will send out alerts if the readings are outside of the given threshold. I would like to thank my mentors, the graduate students that helped me along the way. I would also like to thank the leads and the co-leads of Trend and GradMap. I would like to thank my GradMap peers and my Trend peers, also the audience for supporting and having interest in our projects. Thank you.